The use of one of these non-contact voltage detectors. So you'll see this one specifically has a range of 90 volts to 1000 volts. So it's not going to work on anything less than 90, which we do have in this building. A lot of control voltage is 24 volts. And you'll see that it says read manual, test before and after use. So what that means is basically I'm going to use it on something different, but I'm going to test it before I use it. So there. So the reason I get light here and not there is this is the hot side and this is the neutral. So you always want to test on a known source before you test it on the device that you're trying to verify is off. So in this case, we're going to be doing a light today. So I'm just going to go up and show you what it looks like with the light on, and then I'll switch the breaker off and show you the difference. So this isn't the light we're doing, this is just the light that I'm going to use to demonstrate the principle. And so I've got this bag here. This is electrically insulated gloves. So these gloves are rated to 1000 volts, and they should always be worn when you're looking at something that's live, or you should be wearing them until you've proven that the power is off. So in this case, this light is on. It's pretty obvious the power is on. But if the light bulb is dead, then it's not so obvious. So first I'm just going to show you where this does and doesn't work. So you can see this thing's flashing continuously. That's actually its method of self-testing. That's basically letting you know that the battery's still good in it and that it's on and functioning. So if I run it along here, not really getting anything, right? Because the metal interferes with it detecting the field, because this is looking for the magnetic field that you get when you have electricity. And so, it doesn't really work much, right? You got metal in the way, but over here, this is plastic. So see here, I can put this on here and it lights up because plastic doesn't interfere with its ability to read the magnetic field. So this little box here is the dimmer control for these lights, and the power's coming in here. There's a disconnect up here. After the disconnect, that power branches off and goes into here. So this is where you're going to want to check voltage before you start undoing any screws. Now these gloves, as I said, you can see that they are rated for 1000 volts. So the leather is to protect the rubber. So the rubber is the part that actually is what gives you the electrical insulation value. Leather does have some insulating property, but you're not counting on the rubber to protect you from 1000 volts. You're relying on the rubber, and the leather is there to protect the rubber. Okay. So I just wanted to show you while this light is still live, what you would see for checking voltage. On. Okay, so now you can see I put this in here, right away it lights up. So I've got exposed wires. So that's what we want to be able to compare to. Now I'll go shut the breaker off and I'll come back and we'll look at this some more. Okay, so now I've just switched off the breaker, done the lockout tagout. So right now you can see the light is pretty clearly off. Now you think that should be enough, right? But it can happen that you hit the wrong breaker, and say in this case, like say these two LEDs were out because this has got two ballasts in it. Maybe the other two just happened to die right when you went and switched a breaker that actually turned off two lights at the at the opposite end. So that's the reason you're going to use a tool like this, is because you want to basically have multiple ways to confirm that it's off. So, you know, having your breakers labeled properly is one step. Having, you know, the visual that the light is now off is another just step to help your confirmation. Using this as a third. So, you know, before you could see that this was showing voltage here, and now it's not showing voltage here. Same thing here. Open this up. Before we had voltage, and now we don't. So the reason that you want to continuously add multiple ways of confirming that you're without power and that the power's off and locked out properly is because it's possible to sort of fool yourself and think that you've turned off the right breaker. You know, in the case of something like a heater, maybe right when you turn the breaker off, the thermostat also stops calling. So then there was power, and then there isn't power, but it's just because of a coincidence in timing that it stopped calling for power. So the reason that this type of device is so useful is because with a standard tester like this, most of them, you need to be actually able to get your leads onto bare wire in order to test it. But you can't do that because everything's insulated and you've got wire nuts there. Some meters, like this one in particular, actually have an ability to sense voltage through here where you would normally read amperage. Get that to focus a little better. So this particular meter will let you read voltage in the same way that you can read amperage. But most meters don't do that. So that's why it's really useful to use one of these. And so, you know, the safest way to do it, wear your gloves, at least until you are 100% certain that the power is off, and take every precaution you can to make sure that you're isolated from potential voltage. So right now, it's a little hard to get to. You see what I'm digging out here? So these two lines are your main power coming in to this light. So what's running through here. This is 347 volt. And so I'm going to disconnect this. So now this is my power coming in. So even if for some reason somebody went and removed my lockout tag and switched the power back on, these two ballasts and the dimmer and everything from here down, all of this is now physically disconnected from the source. So that's just one more step. So at this point, because these gloves can be a little challenging to do nimble work with when you're trying to, you know, strip wires and disconnect things, at this point I can consider, you know, it perfectly safe to remove my gloves and work with bare hands, because I know I've physically broken the connection between this light and the main power supply coming to it. So hopefully that gives you a better understanding of, you know, how to use a non-contact voltage detector. And now I'll proceed with going over to the light that is burnt out and actually doing the whole process of locking that out and removing the bad ballast. So if you look, it's kind of hard to see on the camera, but this light here has got 2 of the 4 out. So it's important to make sure that you pay attention to which 2. If I look at this one, like there's 4 quadrants to the LED lights. So you just have to pay attention to if it's the pair going this way or the pair going this way in order to make sure that you're going to be changing the correct ballast. So typically I'll go out there underneath the light and I'll take a photo of it and just make sure I get a clear picture to reference which of the 2 LEDs are off, because that will tell me which ballast I'm going to need to change. Just coming into the electrical room, I'm going to go through the lockout procedure. Okay, so you'll see inside the panel, we've got this chart you can reference. So in this case, it's 4th row in and the 2nd column, which is light number 20. So if I go down here, breaker number 4, and then I'm going to take my lockout tag and this little device. So we've got several different versions of these. Different panels require different versions. This is an example here of a different type of tag, but it only works on different panels. So that one works on this panel. For these panels, you need the one that looks like this. And so to put the tag on, or the, I should say, device on, you slide it over the breaker like that, and then there's a set screw that you tighten up. And so that physically locks the breaker in the off position so that somebody can't accidentally switch it off or switch it back on. And then the zip tie goes through here, and that zip tie actually makes it, it kind of like blocks access to that set screw at the angle that you have to come in at for undoing the lockout device. So that acts as a physical barrier to somebody turning the breaker on. And then you also have the procedural part that explains what it is, your name, date, all that stuff. So now that breaker's locked out, next thing we're going to do is go out there and just verify that the light is actually off. Okay, so now looking at that row, you can see that light is definitely off, and when we go up there, we'll still confirm the power's off. I'll go up on the Skyjack and resume. So one last thing I didn't show earlier when locking out because I couldn't find the key, but I've found it now. You should always also lock the panel, take the key with you while you do the electrical job, so that way the panel itself is physically locked out as well. Video doesn't want to focus. Okay. So when I lift this out, you're going to see there's wires that are going to both ballasts and to here. If you look, I'm going to grab a different set of pliers just to show you the safest way to do this. So these are fully insulated. There's no metal on these whatsoever. And in this scenario, I'm quite certain that the power's off because I had the lights on and I switched the breaker off, and then I had the lights off, and 2 of these 4 lights were still good, which means one of these 2 ballasts is still good. So the first step is making sure you've got the right ballast. So I just wanted to show you before I get started. So you can see these wires coming in here. Those are your supply wires. So you can see the black and the white. That is your power supply coming in. So you see here, there's like a little bit of wire exposed. So that's a spot that you can actually check for voltage if you do have enough exposed wire. Because otherwise, if you've got no exposed wire, then you've got nowhere to double check and verify that your voltage is out. Like ideally, you don't want to see that. But by disconnecting this, now I've just isolated everything here from the supply. So even if somebody were to remove my lockout tag and switch the power back on, you wouldn't have any power past these 2 wires. So you can kind of push those wires up out of the way. And now, because I've disconnected this, we know that there's no electricity coming in and feeding any of this stuff. So that's going to let me work a little bit quicker by not needing to, work with large gloves on. So now you can see these 2. This is your supply lines coming to here and here. And so this right away tells me, so you can see this means that I've changed which was at this ballast before, the one on the other side. And this one I have not changed. Oh, actually, you know what? Let me see if I trace that the right way. Yeah. Okay. And so one thing that, I don't know if we can tuck this up here out of the way. It's kind of a little hard to record video since I'm looking through the camera as I'm doing this. But it's important to like note which wires are which. And it's a little difficult to see on the video sometimes because the focus is a little delayed. But if I tap the focus, you can see there's a different pattern to this wire and this wire. So one of them's got like more of a brown, and the other one's more white line in the black. So you have to make sure that you get all those into the right places as you go through replacing these. Before you disconnect anything, the main thing you want to do is double check that you've got the correct ballast, because this ballast is driving two of the LEDs and the ballast on the other side is driving the other two. And so if you trace these wires, you're going to find some of them are going to be going over here, that's where the control is for the dimmer. So the dimmer wires are going to go to both sets of lights, and then the other wires, you're going to be able to follow them. So like in this case, if you follow this wire here, you can see that it's going down. So see it there? So that lets you know that that one's going there. This one here, a little hard to see in there because it's dark, but you can see that one there. If I trace that one, then I get this one. So that means this ballast here is doing the driver that's under this one and under that one. And those are going this way, like same as the beams. So I know that these are the two that I want because that's what was dead. So now the easiest way to just do this is to just kind of, if you do everything one if you do everything one step at a time, then you're going to make sure that you keep all the wires in the correct spots. So right now, okay, so in order to give myself a little bit more space, I'm going to start cutting some of these too. And so the way I'm going to do it is just make sure I cut. So this side is the ballast side. This is the dead ballast that I'm going to toss away. So I'm going to cut and leave enough wire that it's easy for me to see which wire is going to go where after, right? So I've got the color coding on each of these, and it'll allow me to easily trace them back and get the right ones in the right spots. So unfortunately, these are really tangled around the other wires. And so wherever you're cutting a wire that's, so in this case, these are not replaceable. So because I'm cutting the wire that's on the, that's like feeding to these right now, I want to cut it as short as I possibly can, because I don't want to shorten that wire any more than necessary, because that's just going to make it harder to do future ballast changes. So feed that out, and you'll see, so like this one here, this wire, this orange one, was not being used. And just to make sure that I don't create additional confusion later when I start to wire the new one, I'm going to cut this one back really short so that I remember that this one was an unused connection. And then same, I'm just going to take this and set it aside. And then on my new ballast, because I know that this orange wire was unused, I'm just going to go ahead and cut it back relatively short, just to keep it out of the way. And I'm going to go ahead and grab one of these, and I'm just going to install that on it and tuck it out of the way the same way. So in that way I know like there's nothing to connect that wire to, and it just keeps things simple later on. Whereas all the ones that I'm leaving long, those ones I need to reconnect. So again, this blue one, same sort of deal. This blue one is feeding back to here. The one I cut before is feeding to the other side. So again, for that one, I'm going to cut it as close as possible. I'll fold that one out of the way. So you can see those two were the ones going to the actual LED units, whereas these two here, these are coming off of the wires for the dimmers. So these ones, because I need to, I have to replace these, I'm going to cut these ones back a little ways. And then now I've still got those wires there to know that that's where I'm going to tie in. So that leaves everything in a good way to make it really clear what's going to get connected where. And now I've got the old ballast completely removed, and I can start to install the new ballast. Okay, in order to make this video no longer than it has to be, I just did this part off camera where I cleaned all this up in order to make it easier to see and get to everything. So I just like I explained in the first part, I just methodically went through and did one color at a time. So each color is now prepped. These little wire nuts, there is this strip guide on the back to make sure you're stripping the correct amount of wire for the type of wire nut. And so basically I just went through, and as I did each one, I reorganized the wires in here to make it a lot clearer path from one to the other. And I've prepped everything so that you know, each wire pair is ready to change the ballast. And so you'll see, like on the old ballast where I cut these off, each time I cut them as close as I possibly could on any wires that were that I needed to save there. And then other ones I cut off here when I was first removing it. And then also there's that orange one that I cut in order to make it obvious that that orange one was not going to get used and wouldn't be connected to anything. So putting this back together, or putting the new one in, I'm going to just start with the bottom ones first so that I can get those out of the way and have more space to work. And so you have to watch, just be careful. You can see there's very close similarity between this pink and the red. And then there's also like this one that's kind of purple and the blue. So just, you know, take your time, make sure you're getting the correct wires in the correct places. And so I like to tuck these ones down further out of the way, because you need to keep space that this ballast is going to go in just like that opposite one. So it's nice to have the wires sort of organized and folded down out of the way as much as possible. And then so this one, I'm going to go and then something to note is this one, we're actually going pink to gray. You might say, well, how do you know that the pink goes to the gray? And the answer is you look at the wiring diagram on the new ballast. So you can see here the dim plus and dim minus is purple and pink, whereas on the old ballast, sorry for the focus, dim plus purple, dim minus gray. So just comparing those two, right? Minus pink plus purple, so purple to purple, and then pink to gray. So anytime you have a seeming mismatch in the wires relative to what was previously there, you just make sure you consult your wiring diagram on both the ballasts and figure out what's the necessary corrections to get the right wires with the right pre-existing wires. Okay, so now all those are connected. Next step is to reconnect the disconnect for the ballast. And so really I know the power's off, I've checked it, but this would be the safest way to do it, because since this would have the power if that breaker was switched on, by holding it on the power side with insulated pliers, it would just be a little bit safer, especially because that one had a tiny bit of exposed wire on it. Okay, so now all the connections have been made. I'm going to reinstall the ballast into its little tray that we have. It's really hard to see what I'm doing through the camera. Okay. So now I'm going to tuck these all in, try and keep them the same sort of organization that I had, just so that it's easier next time one of these has to be taken apart. So you just need to make sure all the wires are completely out of the way, and then get that lined up. You have to switch driver bits. This Klein tool is really great. It's got quite a good selection of driver bits on it, because you can store everything up to a ½ inch right on it. And that's it. So that's the whole process from start to finish. Now I'll just go down and take my lockout tag off the breaker and turn the power back on. Hope that's helpful.